So here we are in the ex3 project, and we're going to look now at test fraction multiplications. That's the last method we'll look at here. So again, you can see that what we do is we're going to have a create call, observable create, and we're going to give it something called a big fraction emitter. So let's go down and take a look at big fraction emitter. And here's the big fraction emitter. What that's going to do is it's going to use the range method to go from 1 to s max fractions. So in this case, from 1 to 10. And we're going to emit basically a big fraction. So you can see every time through here, we're going to make a new big fraction, random, unreduced. And if an error occurs, we say on complete. If on complete occurs, we say we're done. So that's what we're going to do. We're going to go ahead and generate essentially 10 of these things. I believe if we go look at the value of s max fractions, that's 10. And so the big fraction emitter is going to spit out 10 of those guys. And that's all going to happen in the foreground thread. So this is not running on subscribe on or observe on. It's just all running in the foreground thread. We then go ahead and use the flat map concurrency idiom. And what we're going to do here is for each unreduced fraction that we emitted from our randomly generated set of fractions from 10 fractions that were randomly generated and unreduced, we're going to go ahead and use flat map, and we're going to call the results of reduce and multiply fraction. So we'll take a look at what that does in a second. But reduce and multiply fraction takes an unreduced fraction, which is what we got here, which came up from the emitter. And then we're going to have that run in a thread from the computation thread pool. So let's go ahead and take a look at reduce and multiply fraction. So here is reduce and multiply fraction. You can see what it does is it returns an observable of big fractions. So it's basically a factory method that returns an observable that will be signaled after all the other processing takes place. And what we do here is we say, we're going to go ahead and take the unreduced fraction. That's what got passed to us as a parameter. And we're going to say from callable. So we're going to go ahead and call the reduce method to reduce the unreduced fraction, which could take a while because these could be very large. So this is going to convert this big fraction into an observable using the from callable method. And to make this be part of the flat map concurrency idiom, we're going to run this computation in a background thread by calling subscribe on the scheduler that's passed in, which in this case was the computations thread pool. Okay, so what that says is do this reduction in a background thread. That's one thing that we're saying. Then what we're going to say is for each reduced fraction that got run in that background thread, then what we're going to do is we're going to go ahead and take that reduced fraction and we're going to call the multiply method on that reduced fraction to multiply it by this big reduced fraction. We've seen that before. It's just a very large constant reduced fraction. And so we're going to go ahead and make that into an observable. And we're going to say, do that multiplication in the background as well. So we're doing the reduction in a background thread in that common thread pool, the scheduler, that's the computation thread pool. And after that completes, we're going to say, then go ahead and compute the multiplication in a thread in that computation thread pool. So by putting the subscribe on methods after these things, what we're basically saying to RxJava and the framework is run these things in the background in the computation thread pool. So that's what's happening here. And that is returning us an observable where all those things took place. And if we then pop back up here to where we called this, that will then go ahead and do all those computations in all these different threads in the computation thread pool. And then when we're done, we're basically going to combine things so that you can kind of think of this as kind of like, split, apply, combine in a way, but there's no splitterator per se. But we're kind of using the flat map idiom as our implicit splitterator. And we're mapping those things to run in those threads. And then what we're doing is we're collecting the results into an array list, adding each element as they finish to the end of the array list. And that's going to end up generating the an observable that we've collected this stuff into. And then what we're going to do here is we're going to go ahead and map that using flat map, doing the sorting and printing. So sorting and printing, in this case, it's just reusing the exact method we looked at before. So nothing has changed there. It's the clever method that uses the AMB array. But once again, we're doing all this stuff concurrently, collecting into a list, and then we're end up going to do a flat map completable on that list in order to be able to get it all sorted and printed, and we get a completable back, which is what integrates and synchronizes with the async tester framework. Okay, so what I had told you before was we'd started this computation running in the background. Now let's go ahead and take a look at what the results look like for both of those methods. So if you take a look at the run, you can see here's what we got when we called test fraction exceptions. And as you can see, when we tried to divide by 0, we got an exception and we logged that. And then we filtered out anything that was a 0. So you can see that the final result didn't have that. Here is then test fraction multiplications. And as you can see that it went ahead and did the sorting and the reduction, and then it prints the sorted results. And I don't know whether heap sort finished first or quick sort finished first. It doesn't really matter. Whoever finished first, the other one was ignored, and we ended up printing the results. And you can see that these are sorted in increasing order. Okay, so that is the overview of many different examples from RxJava's Observable. And at this point, you should know an awful lot about all kinds of different cool features, including subscribe on and observe on, and the flat map concurrency idiom, and the use of completables in order to let the asynchronous tester framework wait for everything to finish. So this should give you more than enough information to do all the programming assignments, pieces, and also to be much better positioned to understand how reactive streams work, especially in the context of asynchronous and concurrent programming.